So, good evening, gentlemen, and I really do hope that we have some ladies over here, at least a few. Why this live stream? Recently, I discovered that I kind of started to like making live streams, so probably slightly more of the educational materials will be actually handled in form of the live streams. This kind of allows me to have a contact with you. You can ask questions in the chat and so on and so on and so on. And to be honest, the whole process seems to be working and seems to be both satisfying my need to do something interesting after the full day of being a software developer in my day job, unfortunately, and for you to learn something about stuff. So, in today's live stream, we will be talking mainly about the resource mapping, why there is no resource mapping, the resource mapping from Betaflight, for example, and how to live with INAV when there is no resource mapping. I know that this is one of the mostly desired features in INAV. However, there are at least several reasons that we never decided to port and decided to implement the resource mapping from the Betaflight into INAV. And the main reason is the Betaflight version does not really solve all of the problems. Yes, it allows you to map motors wherever you want, and in some of the cases also allows you to map servos whenever you want. And this is working Betaflight for the quadcopters and other multi-rotor drones. However, when we go into combining the motors and the servos on one board, there is a hardware limitation of the whole STM32 architecture. Despite what some people Despite what some people think, you cannot map any pin to any function. And even if you map some pins to some functions, there are external limitations, for example, DMA channels or timers. And in case of the resource mapping, the timers are really the main limitation of what can be put on which pin and what this pin can be doing. And on top of that, we have the very, very old legacy approach to solving this problem that comes from the multi-wii. Maybe not directly multi-wii, but from the base flight and the clean flight, INAV, and so on and so on and so on. So today I will show you, how to build yourself your own very custom target. Because building your own target in INAV is kind of simple. And if you want to build your own firmware, there's really like you type one command and you should be ready to go. If you're at least slightly technical and can type on the keyboard and, like, let's say, copy paste some of the comments, you should be ready to go to compile yourself an INAV. And when you can compile yourself an INAV, there is really a short distance between compiling and modifying the target files in the way that you can almost, this is very important, put any output into almost any function. Of course, please keep in mind that not everything is possible. Not every pin can be used as the output. Not every pin can be used as an input, as the function. There might be conflicts on timers, DMAs, and alternate functions, and so on and so on and so on. But if you only want to remap the motors, and let's say move the servos into one of the pins that originally is assigned for the motors, this sometimes you can do. But to be able to do it, first step is, of course, being able to compile yourself the INAV, because with possibility to compile INAV, you will not go very far. Let me close the boards that you will not need. No, I will not need. How to compile INAV? Good question, and luckily we have a pretty good documentation on how to do it. And if you are using any Linux, basically any Linux, Mac OS or Windows 10, you are almost ready to go, especially when you are on Linux, because you only have to type some of the commands that's located in the docs development Linux. You type what's there and you, come on, load. you type what's there, and you should be able to build anything. Almost the same process go for Mac OS. Unfortunately, when you are with Windows, it's slightly more complicated, because building on native Windows is no. You really do not want to do it if you really don't have to. This is why majority of the people with Windows are using the so-called WSL, which is a Linux running on Windows. It's almost like a virtual machine, but slightly more tightly integrated with the whole Windows. And on the latest builds of the Windows, it should be even enabled by default. If it's not, then we have a pretty nice instruction of how to step in environment. You just have to follow the steps in the building Windows in Windows 10 Linux some system, and this basically requires you to go to the Windows Store. Windows Store in the Microsoft Store. Search type for Ubuntu and installing the latest Ubuntu. Current master of the INAV will not build on, well, there will be problems when building with the 1804, so we suggest building on 2004 LTS version of the Ubuntu, and without much problems you should be able to do it. Then of course you have to follow the guide how to do it, and in some cases you have to resolve some of the problems, like for example config log failed, or the very stupid system where the syntax error unexpected. This is peculiarity of the Windows, but does not really, it's simple to fix because there are at least 2, maybe 3 even versions of how to fix all those problems. And when you are done with that, you have 2 options. Options number 1 is to use some kind of the terminal, like if you open the, if for example you open the start menu start, you can open the Ubuntu program, which puts you in the Ubuntu context and the command line, or use Windows Terminal, which is kind of nicer option probably, and you only have to go there and you are on the Windows Terminal. You go into any command panel. You go into any folder you want and you clone the INAV into it. Now, at this point, you can use different tools to edit the source code of INAV. It's really up to you. You can use Notepad or whatever. We, however, in the developers world say that probably the Microsoft Visual Studio Code is the best option to do it, because it works, it's free, it's fast, has all the options and pretty nice support. If you do not want to go into details, then you just install the Microsoft Visual Studio Code and you are there. If however you would like to be slightly more up to date, there is a couple of plugins, that extensions, that how they call it, that might help you with configuring the Visual Studio Code to be running with INAV and to help you with the development. First of all is the remote WSL. The Visual Studio Code even will tell you that after you will open the folder where you checked out the INAV with open folder, will tell you, do you want to reopen this folder in the WSL, and yes, you do want to reopen this in WSL. And the other useful is the C/C++ extension from Microsoft that basically gives all the C and C++ magic into the Visual Studio Code and allows you for auto-completion and navigation and other cool and fancy features that all the developers like so much. And now when you have this step done and you think you can start building, you have to basically start building. How to build INAV? One more time, you have 2 options. Either you will use some kind of the terminal, and for example the Windows terminal from the and work from the console, or open the terminal in the Visual Studio Code. And then when you are in the folder of the INAV, you type the cd, no, we are in the cd build. If the folder build is not existent, that means you have to make yourself a folder called build, and then we have to initiate something called the cmake. Cmake makes all the magic with building INAV. So to handle this, type just cmake dot dot. By the way, this is pretty nicely described in the development docs for the Linux, with the links also for the Windows and so on and so on. So you definitely will not be lost when trying to go into this moment. CMake takes a while to run, but once I started, I cannot really turn it off because then it will go crazy. So we have to let it run. This is not the fastest laptop ever, the fastest PC ever, and unfortunately it takes quite some time to run the full CMake. So right now I have a moment to answer potential questions from the chat. So what we have there? Oh yeah, Kali Sislander says that he used the mixer wizard from the INAV 2.6 configurator, and it allows you to remap motors in the any order you want. Yes, but this is only working with mixer. When you want to move servo to a different pin, the mixer cannot do it because the pin assignment is then driven by the code itself, so it's kind of different. But if you really want to change the motor order, then the mixer inside of the wizard is really everything you want. 13 FPV, yes, you can also build INAV in Docker, but because this is a different project, it will start a different Docker instance with a different container, so it will not really reuse what you have set up for Docker for the beta flight. It will just spin up the separate container inside of the Docker. Platform IO, Brian Webb as the web interface, the programming interface, the editor. The Platform IO is, from what I know, based on the Visual Studio Code. So this is pretty exactly the same. Yes, Darren, yes, it's pretty slow for the i7 10th gen, maybe 9th gen, I don't know. I don't remember which generation of the i7 this is, because this is my laptop. This is Surface something, I don't know, from last year. Yeah, but still, it's a laptop, so it rather cannot be super fast. And also the OBS running in the second window and the streaming does not really make the process much faster. Okay, and it's done, and we are almost ready to build. And now to build any target, the command is super simple. You just type make and the name of the target. I will be using the Matek F722, so Matek F722, build Matek F722, hit enter, and it will start building. Of course, it will take a time. I do not want to break the process right now. I'm just showing you how this basically will be looking like during the changes. So Micra10 FPV asks if there is a way to change motor direction in INAV, not BL-Heli suite. No, rather not. I know it's technically possible for the INAV to speak to the BL-Heli S and BL-Heli M, because the protocol over there is open and you can just reuse it. However, the BL-Heli 32 has the closed source protocol, and this is not doable, so you have to, unfortunately, you have to use the BL-Heli suite to connect to those ESC. I'm not sure if maybe Raceflight Falco X is doing something with that, not really 100% sure. But no, to change the motor direction, you have to use the BL-Helis or just swap any two wires from the ESC to the motor. So as you can see, the building of the target is running. 0%, it's always showing 0%, but it's cool. When it will be done with the compilation, it will then link the the compiled files and give us a pretty nice hex file that we will be able to flash. Okay, this is slightly different question, not really about the building INAV. Then multi crashed, and when the VTX antenna snapped off, the VTX is not turning on. Do I think it was killed by the time it was left without an antenna? This or just the crash? It's really hard to define. It all depends for how long it was sitting with the antenna disconnected. Usually when the antenna is disconnected and VTX is working, it's really burning the power amplifier on the antenna output, not the input from the battery. And if it's even not blinking any lights, that means probably the power input is broken, so maybe it is overheated and maybe just died during the crash. Mr. D. Darren, I have no bloody idea. To be honest, I never checked that, so I cannot really answer your question about the technicalities of the Visual Studio Code. And now Mike's Adventure would like to build an X-Class drone, but using 12 motors and three controllers from one output. Yes, this should work. You can connect at least a few controllers, yes, to one output, and will work. And this should work without much problem. I'm not sure this will make sense from the flight perspective, because probably you will not really get any special gain from that besides being very heavy and extremely power hungry, but maybe, who knows, maybe that's the way to do it. And no, H7 can GFPV is not really happening right now. Okay, the INAV is building right now, so let's go to the quick guide of how to remap motors as servos. When you open the source code of INAV, there are several folders, and the folder we are interested in is called src/main/target. In this folder, there are subfolders, one subfolder for each target. So if, for example, you are using Matek F722 like I'm using today on my development board, which is right now over here, I will have to open the folder called Matek F722, and then I will find a couple of files. First, the CMake list. This is mainly about the family of the MCU this target is running. You do not really have to change anything. The target.h has the definitions, for example, how many serial ports, to which pins each serial port is connected, and so on and so on and so on. When you just want to map the outputs to a different places, you do not also have to touch the target.h. However, if, for example, you will want to, I don't know, remap one of the serial ports as I2C, or change I2C pins into the different one, this is the file you will have to be working with. However, today we will be working only with the file called target.c, which almost only holds the PWM outputs and inputs. In case of the Matek F722, it has several inputs. Actually, no, it has one input listed over here and several outputs. The input number one is the PPM input, and bear in mind that we try to put a function on each of the pins. So if there is a comment at the end saying that this is PPM, that means this is the PPM input, and S1 will mean output 1, and S2 output 2, and so on and so on and so on. And also we have the output for the LEDs, and we have a couple of outputs on this board mapped from S1 to S7, which are motor and servo outputs. And what's really interesting in our syntax is the column 1, column 2, column 3, and column 4. Column 5 and 6 are not that interesting. We will not be talking about them at all. What's really interesting in our case is, first of all, column C. Column C tells us, the third column in this timer definition, actually def underscore timer. Column 3, the third argument for the function, is the information on which pin the output is assigned. In this case, output 1 is connected to port C number 6. If you will want to find out which functions can C6 make in the STM32F722, you will have to find the datasheet for the MCU F722 and check exactly what port C output 6 can do. If from time to time it may be, for example, able to be doing, I don't know what, serial or I2C or inputs of some kind or any other functions, then you will be able to map the pin into something else. But usually the outputs are organized in the way that it's really hard to reuse them for something else, and usually they are outputs. So this is the first one. And the second is the argument 1 for the dev team, which is the timer. What's the timer? Timer is exactly what the name says. It's a timer. It counts time between events, and thanks to the usage of the timer, we can either put the output high or low, and thus inform the ESC about the pulse length, the output power the ESC should be driving, and also in case of the D-shot and the digital protocols, it also tells the ESC, it also allows us to encode digital series of bits into the port to drive the D-shot. This, however, is transparent, and the way of changing motors to servos and servos to motors is exactly the same for all the analog and the digital protocols. It's just basically the same. So what we know? We know that S1 is assigned to timer 3, S2, S3 and S4 are assigned to timer 8, and then S5, the output number 5 on the board, is one more time assigned to the timer 3. And this has the effect that S1, output 1, and S5 has to have the same function. You cannot have multi-rotor motor on S1 and multi-rotor servo on S5, because then the frequency of the timer is the same for all the outputs connected to the timer. You cannot run the multi-shot on channel 1 of the timer and the servo at 50 Hz on the channel 2 of the timer. This will just not work, and all the outputs on the same timer has to be assigned to the same function. And then on the fourth argument of the function, we have the information of to which function the output should be assigned. So S1 assigned to timer 3 channel 1. By the way, if you have timer 3 channel 1 on one pin, the other timer 3 has to be a different channel, and also not every channel will work. There might be conflicts. This is also sometimes complicated. And we know that multicopter motor or fixed wing motor, and this is the output mapping for the S1. And S2 on the timer 8, it's multicopter motor one more time and fixed wing servo. Then 3 and 4 will have exactly the same usage as 2, because they are on the same timer, although different channels, while the S5 will have multicopter motor and fixed wing motor again. And now what we can do? For example, can we assign extra servo on the multi-copter configuration on any other pins that S1 to S4. Yes, but it cannot be S5 because S5 shares the same timer as the S1. However, the S6 and S7 have completely different timers assigned, timer 4 and timer 1. This means we can have two servos in the multi-rotor configuration on the S6, and this is even right now happening right now on this board right now. So there is not really much to do. We can also make a tricopter. In case of the tricopter, if you'd like to have a tricopter, we can assign MC servo on output 1 and on output 5, because one more time, remember that timer 3 and timer 3, and after compiling our targets and choosing the tricopter option, the servo would be on S1, motors would be on S2, S3 and S4, and so on and so on and so on. So this is almost exactly like you do the resource mapping in INAV. Now, gents, do we have any questions before we will proceed? Waiting for questions, waiting for questions. If there will be no questions, I will just continue with the topic. Okay, there are no questions, so let's continue with the topic. Brian Webb is asking, can I talk about configuring user switches? You mean programming framework or what? Modes or what? You have to be more specific, mate. Okay. Okay, Chris Archer has a question. What about putting everything on 50 Hertz? This will kinda work, but this is only a hack that kinda almost work. The assignment inside of the INAV still will kinda go bonkers because this is almost like the edge case of this, and I do not really recommend it. Okay, so this is number one. Let's then answer another question. Can every flight controller be used on the on the fixed wing configuration? And the answer is not. Let me quickly try to find the flight controller that cannot be used, for example, on the fixed wing. I remember there was something because even a few weeks ago I had to inform someone that this is not possible. No, this is not the case. Beta flight 4. Oh, I remember. Hack RC. No, HGL RC, not Hack RC. No. We are not doing this again. Where's H? So, okay. HGLRC F722. The full, the big 36 by 36 millimeter version of this board can be used both for the multi-rotor and the airplanes, because it has 8 outputs broken out, and you can connect out 8 outputs, and outputs 7 and 8 are assigned as fixed wing motors, while the targets from S1 to S6 are only assigned to the servos. However, the mini version of this flight controller has only 4 outputs. And that means that if you will look at this is only an example, of course. If you will look at the timer assignment on the outputs S1 to S4, we will notice that all those outputs that are broken out on the mini version of the HGLRC F722 are all assigned to the timer 3. And that unfortunately means that all the outputs has to be assigned to a same function. And in this case, it is fixed wing servo. We can change it to fixed wing motor, but then there will be no pins for the servos. So not every flight controller designed for the multi-rotors can be used on the fixed wing application because just it will not work. On the same note, if for example we will see over here on the FreeSky Pilot, this is a flight controller that I'm not sure that hit the market yet, but probably at one point will be. You will notice that this board really allows you to do almost anything you want, because not only it has how many 1 2 3 4 5 6 7 8 9 10 outputs for the multi-rotors, and you can like have a decacopter. Anybody ever built a decacopter? No, I really doubt anybody ever built a decacopter, because that would really not have much sense, and two servos. And for the fixed wings, it has 2 motors and 10 servos. But please do remember that because S1 and S2 are on timer 3, they in every configuration have to share exactly the same function. Now let me go to the chat, and Brian Loudmild, I think that's correct pronunciation, asks what's the real advantage to compiling your own software, because it's the only way to remap the outputs in INAV. You cannot do it in other way. You cannot just type resources and do it. You have to compile your own version. Mick V asks, will INAV stop you from running fixed wing on the incompatible FC? No, it will not stop you. It will allow you to solder anything you want to anything you want, and will allow you to power this up, but then depending on the real output allocation, it will send signals to the outputs. And if, for example, ESC will receive the 50 Hz signal that was supposed to be targeted for the servos, ESC will say, okay, I'm accepting the standard PWM protocol. I will work without absolutely any problem, and everything will be just fine besides the flight performance. However, I don't remember the exact frequency, but I think the one shot is 2 kilohertz and multi-shot is about above 8 kilohertz. I think so. I don't really remember the exact value. It will try to put this signal on the servo. The servo will either work or will fry itself up by trying to adjust and reading complete garbage, and this actually can destroy your hardware. This is possible for the servo to just be destroyed in the process of connecting servo to a motor output. This of course depends on the brand of the servo, on the type of the electronics, and maybe someone thought about some kind of the limitations, but in case of many cheap servos, this is just no-go, and the servo will either go complete bonkers and not work, or will release the magic smoke and be destroyed. Ryan has a question. If he remaps inputs, then will the INAV configurator in the ports will they show up there correctly? Yes. The firmware reports to the configuration the assignment of all the ports based on what's compiled into this, and the configurator will show you correct assignment on the pins in the outputs. This will work, yes. Practic PPN writes that so the timers are limited, and if I want to turn a motor output to a servo, can I use the timer for any other servo for it? In other words, how many outputs can I connect a timer to? This depends on the number of the channels of the timer. You have to always refer to the datasheet of the STM32 is used on your controller. However, in most of the cases, there are 4 channels on all the major timers. So you can max on one timer, you can use 4 different outputs, and this will work just fine, as long as, of course, the frequency on all the pins connected to this timer have the same frequency. But also you have to remember that there might be conflicts between channels, and not every channel can be working as you think it will work. So you have to refer to the datasheet of the STM32. And also that only in some cases you can change the timer assigned to an pin, to an output. There is, it's not a complete matrix of I'm assigning any timer to any output. No, some pins on some ports can be connected only to some of the timers, and in case of the other, it will just not work. So there are extra steps. I'm not sure if I have somewhere right now the data sheet for this. Let me make INAV development. No, this is not INAV development. Data sheets? Where's the data sheets? Electronic data sheets. No, so maybe I should start searching for it. STM32 documents. No, right now I cannot really find the document, but we can STM32 F722 reference manual. Once upon a time, I really had all those PDFs on my drive, but I don't think I have them anymore. Technical note will be able to find. No, this is the RATA technical note, application note, programming manual, data sheet. This one or this one. Let's open if this is correct. By the way that the STM puts the documentation on their CPUs is highly technical. If you don't know everything, then you will never know everything. Okay, so here we have mapping of the pins to the pin name internally and options. For example, on this CPU, the PC2 can be used as I/O with SPI2 MISO. OTG, this is not relevant, and can be assigned to one of the 3 analog digital converters. Oh, this is interesting. For example, the PA0, okay, no, PA1, port PA1, based on the documentation for the F722, can be assigned to a timer 2 channel 2, timer 5 channel 2, can be universal synchronous asynchronous port RTS or RX on the serial port 4, or quad SPI BK1 IO3, whatever. So this is the information of which functions the port can be used. If we go back to the F722 we were working before, and we'll try to find the PC6. So what else can be used in case of the PC6? Let's then try to find PC6. Where is PG? PB. It's not the best documentation ever. PC8, PC9, PC10, PD. Now I have to scroll to the top of this table right now probably to find the PC6. Ah, this is not in order. Amazing. So let's just... Oh yeah, we have it. So PC6 can be used as timer 3 channel 1 as we can see over here, timer 3 channel 1 or timer 8 channel 1. So this is possible to remap the PC to remap PC6 into timer 8 channel 1 and use this thing with other outputs on the timer 1, but there is no gain because then all the 4 outputs will have to have the same output type. Okay, I think that covers this this part of this video / live stream. And now also something very important. After you will make the changes to the timer allocation and function allocation, like what we did originally, which was assigning the S1 as the MC servo, you of course have to compile it. So you have to make the command make the name of the target you were modifying. I'm modifying MATEC F7 to 2, so this is what's gonna happen. And then to answer the question, will the INAV know, the configurator know that the output changed? I will show you that yes, it will know. Let's wait for the compilation to be over, and then I will flash it to the board, and we will have a proof that this is working exactly like we expected this thing to work. So right now the compilation should be slightly faster because it only had to compile target C, and now it's linking all the previously compiled files. So the configurator will be here. Yeah, the fastest laptop I ever owned. Mike's Adventure has a question. Have I ever put a LiDAR sensor on a quad instead of the GPS? Instead, no, because it's not really instead. LiDAR as a LiDAR is only a device that can measure the distance from itself to the ground or any other obstacle. To have the upflow, to keep the quad orientation based on the shapes on the ground, you need an upflow. There is this, wait. There is this board from MATEC called the MATEC upflow sensor. I have it over here on my PIRX 7. I have it configured, enabled, but I'm not really using this this much because in the places where I'm flying, there is not enough of the patterns on the ground to be able to play with that. But in the meantime, our firmware compiled, and we have the hex file in the build folder. So let me flash this to my board, and MATEC F7 to 2 we compiled today. So let's flash the firmware. Flashing. MiGV asks, is it possible to add an INAV target that to the official list of the flight controllers, like for example JHE MCU F7 dual? Yes, it is possible. If we one more time go to INAV repository, in the docs folder there will be a subfolder called policies, and there is the file called new hardware policy, and this file holds basically, no, I have to use less word basically I have to use less basically, and then this file, this document contains all the rules and expectations for the hardware to be officially supported by INAV. And this usually means that the samples of the boards have to be granted as a donation to the INAV team, and this is almost only limitation, practical limitation. So after we compiled and after we flashed and after of course verified, And after connected, let's go to the outputs and no, not the outputs. Let's go to the mixer. And now, quad configuration. You see S1 previously used as the motor. Right now, what was not assigned on the motor because the S1 is right now only can be used by a servo. If, however, I will try to let me make the slightly bigger. If now I will try to add a mixer rule, the servo one was immediately taken by the S1. If I will open the tricopter and load the mixer, you see servo, the only servo put in the S1 and the S2, S3 and S4 assigned to the motors like they should be. So yes, the configurator knows how the outputs are mapped because there is a special MSP frame that brings the information. Okay, gents. Is there anything else you would like to know about building your own targets with INAV? We still have something like the 15 minutes. I have free to answer all the questions you would like to know. And by the way, please do remember that we will meet tomorrow at 7 p.m., so exactly the same time as today, on the full-blown FPV live stream when I will have 2 hours to answer almost all of your questions, not only about the INAV. Okay, and there is a question from Copter Flights. What means full duplex serial port? Full duplex means that there are 2 lines, one used to send data from device A to device B, and the second from device B to device A. That means the bidirectional communication can be happening in parallel. In the same time, device A can send data to device B, and the device B can send data to the device A. In the half duplex communication, usually only with one signal wire, they have to, it cannot happen in parallel. When one device is sending data, then there is a different time slot when the second device can send data the other way. So in general, the full duplex is much faster than the half duplex because the bidirectional communication can happen without having to wait for the time slot in the transmission window. Brian Ladmiraut also has a question. Can somebody use extra PWM outputs to control external devices using relays? Yeah, kinda, yes. Please do remember that you cannot drive a relay directly from any outputs on the flight controller because you will just fry the flight controller and that's all. However, there is something in the INAV that's not officially enabled anywhere, which is called Blinken lights. I do not remember the exact name, so Spectrum, servo gimbal, safe homes, rangefinder, programming, LEDs, lights. Yeah, there is a special define you can compile into the output and assign the lights to almost any output, and yeah, you can enable a relay based on that. By the way, with the INAV 2.6, it will be possible to connect a board like that. You can see right now on the screen. This is the very simple port expander and the series of Darlingtons. This is ULN 20003. I don't remember the name. ULN 2803, which gives you 8 outputs from the flight controller, and each output can be up to, I don't know, 150 milliamps. There's also a configuration somewhere, documentation for this. Let me check the not here. Okay, it should be somewhere. So let's go to the INAV and INAV hardware, and now in the INAV hardware, IO expander. Yes, there's a documentation for the board itself. Two simple electronic components soldered into one board, and the load on each one can be how much? 300 milliamps. So not that bad. So yes, you will be able to, with this thing, you will be able to connect the relay, and this thing can be programmed using the programming framework in INAV 2.6. If you don't know about this interesting project I did a few months ago, I'm just posting the link right now in the chat. Cursed FPV. Well, you missed the stream. Don't worry, tomorrow would be another. And Cursed FPV has a question about the Matek H743 and M9N and how screwed he is. In case of the H743, yeah, you are kind of screwed because probably INAV 2.6 will be released without H743. However, the driver for the M9M was already merged, and INAV 2.6 will be released with this driver. And even mine, Pirk 7 already has the Matek M9M GPS over here. It's a big GPS, but yeah, it's really very sensitive and gets a lot of sats and has super nice accuracy, because the jitter on the velocity, even though this is stationary, is, from what I observed, half of the jitter comparing to the M8N. So it really should give a pretty nice accuracy on the position hold. I have not tested this yet because, well, the weather sucks and I have no idea when I will be able to fly, to be honest. But so you are only partially screwed. And what? 8 minutes. Okay. In that case, I think we will be slowly ending. By the way, this is something I shared on the INAV FPV group, INAV group on the Facebook. And I'm thinking about Friday live streams with INAV and other topics. So if you have suggestions about the topics you would like to have discussed in this form like we had today, then please drop me an email, pspichalski@gmail.com, and I'm pretty sure that majority of you knows how to contact me. For example, on the Discord channel associated with my name, where, by the way, is the Discord link. Where's the invite to my Discord? Invite. Hello, invite. Where can I find you? Of course, I cannot find you. Let me find it. Of course, I had to lose it. Okay, no. So create invite, and now edit invite link, expire never. Okay, and now the invite link to the Discord if you would like to contact me and give me a suggestion for the next stream on Friday next week, then be my guest. And for now, this is probably all. We will meet tomorrow at 7 p.m. Central European Time for the regular weekly FPV live stream, when we will be one more time talking about anything you really would like to talk to me. So, thanks for watching, and until the next one. Bye bye.